awesome, folks. How's it going? I just realized my mic was on mute, but how's it going? It's a Tuesday afternoon. I'm sure y'all are probably just back from college or bunking it one way or another. I'm glad it's going great for you, Adarsh. I see Vishal is here as well. Hi, Vishal. And I see we have a small crowd today, which is good. I always love small crowds. But yeah. We're gonna wait for another minute or two for people to trickle in because there are not many people in the chat apparently. But yeah, let's keep the discussion going. Have you all attended any GHW sessions till now? Is this your first GHW session ever, or you all are frequent at GHWs? Tell me, what brings you here? First in IST. I'll take that. I'll take that as a huge honor to be the first person doing a GHW for you in IST. I think there aren't many sessions in like core IST this time anyway. Most of your coaches in the program graduated this year and have started their jobs, so they're just still, hi Shivam. All right, folks, I'm excited. I am doing this track after a long time. I think I did it last in March, maybe. I don't even remember, and I don't see any of the people who are here regularly. And if y'all are here, I don't see you. Hi there, Dreaming Godball. So, oh yeah, so that was a completely different stream that I did. APIs are way out of my comfort level, but like IoT is something I do like. I love talking about IoT, PPT, no PPT. I end up talking about it anyway. I know, I'm going to talk about my setup a little more. I love showing it off. I like to call it, I'm inspiring y'all, but it's really showing off. Hi, Heath. Hi, Prasanna. Hi there. I1313. Y'all come up with such creative usernames. I think I end up doing a lot of tongue twisters just by taking the stream. But okay, we're a small crowd today, which is great. I do like an interactive stream. I usually don't go on into a monologue without making sure you all are on the same page. Hi there, Jedua. Long time indeed. So we don't have a lot of hackathons. This is the shoulder season for hackathons. So you see coaches a little less. This is like our vacation time kind of. But yeah, it's a small crowd. I don't go into monologues, so I'm usually gonna ask you a lot of questions, pester you all, which is why it might seem like a slow stream. In which case, you all can always fast forward it later and watch it again, right? But if you all are here, try and interact. I promise you, this is some of the best conversations y'all can have here. One of my favorite things, like in the API week, I do this intuitive exercise. We'll do it today as well, and some of you all came up with such beautiful examples, and I still quote them every time I go to a meetup. So you all inspire me more than you all realize. So interact, and I promise you, I'll give you the credit wherever I can, right? Hi there, Krusty Kunal. Awesome, folks. So I'm going to share my PPT since we're already into the time. It's going to be a nice, it's not slow. This time I've tried to ramp it up because I've realized if you all are new here, I do a lot of streams. I haven't been doing it the last 2 months because well I've made some very smart decisions, but this time I've tried to keep it a little fast paced, so we'll be covering a little more, but overall I'll be covering almost the worth of 2 tracks, which is basic electronics that I took at some point during the past GHWs, and IoT, right? Because I have a feeling IoT alone can get a little abstract and a little, you're just following instructions and you're not really understanding anything. Okay, so I'm going to start by sharing my PPT. I see a lot of you all have just joined. Keep the comments going. I get distracted, yes, very easily, but I'll make sure that each one of you gets answered. Oh, really? Yeah, I have some, which is so ironic because none of the people whom I know, I'm very sure, who would have hyped me up aren't here. Well, programming language, you might want to get a little bit of practice in CCPP, but it's not necessary. Ask me questions. Worst case, I don't know the answer. We'll search for it together, right? We always do that, right? We're not doing a coding session today. We're using simulators today to kind of, make our own circuits, and then we'll be studying the existing code. And from tomorrow, which is IoT track part 2, we'll be going over actually writing some code for ourselves, and you'll be learning something new called an RTOS. So I'm excited. I am not very good. I'm still getting better at teaching RTOS. So please ask as many questions as you like, because it can get a little confusing. Awesome question, Adarsh. That's the question I'm going to be asking you in a minute. So let me quickly start by sharing PPT. Y'all can tell I get lost easily. Also, there's this thing I do where I share the PPT onto StreamYard, but there's another button I need to click to get it onto the screen. So there's a lot of times I've been missing out on that. So scream at me until I share it. Oh, see, I know this is the person who's hyping me up. That's okay, Yash. I'm glad you dropped by. Yash is one of the most regular hackers. See, I don't forget hackers who interact. So y'all interact, I'll remember you, I promise. Alright. I'm sorry, no surprises here. I have no giveaways in any of my sessions that I know of till now. But I will see if Mary can, maybe give me one giveaway. I've never done a giveaway before, so I'll definitely ask her. But right now, none planned for any of my sessions, just as a heads up. Alright, share screen. There we go. And share to the screen. Yeah, that I don't think you'll let that happen, Yash. I trust you to not let me do that. All right, folks. So today we're going to be learning about IoT, and if you're confused about the theme of my slides, well, one, I did not want to go hunting for a new theme. I did not like my Microsoft themes anymore, and I thought, what's best to keep people's attention, to have a theme that makes no sense with what I'm doing. So I have been using this theme a lot in my presentations, and there's a chance you'll see all of my slides this week done in this theme. Yeah, I hope you'll enjoy it. Oh, you've attended before, Shivam. Welcome back. I'm glad you think I give a lot of knowledge. Hi there, Paulav. I hope I got the pronunciation right. Hello, Amit. You say artistic, Amit. I really want to see you in a Bob Ross now, Amit. But also, I usually get very hungry more than halfway through GHW, so I've kept a theme that, reminds me of the good food out there. Okay. All right, folks. What are the questions we're answering today? So I've kind of tried to make this into question answer format of a PPT. I'm experimenting. Y'all can be blatant, like blunt about, okay, this is a stupid way to do it. We don't like it. We don't understand things, because I do take your feedback seriously, right? That is an amazing question, Tintin. So, Tintin, we are doing IoT today, and if y'all haven't already, I suggest y'all check into the session, the link of which I've shared in the chat, so that y'all can check in and grab those extra community points. And what we'll be doing today is what I'm just about to cover, right? So, we're doing IoT part 1. We're doing a lot today. We're gonna first say hello to each other. I have a very, very nice section carved out, for you all to get to know me, where I show off my setup and everything. And then we'll go into what's IoT. Before we dive into that, we'll do a nice exercise. The whole point of a stream is, we're live. Y'all can pester me. I can pester y'all, and y'all know that I don't leave an opportunity to do that. So I'll be basically making you run around the house, grabbing some pictures, and we'll post it on Discord, and then I'll share that, and then we'll dive into the actual definition of IoT. We'll discuss what's IoT and IoT. If you don't know right now, that's fine. That's what we're going to be covering. How do we learn a lot of electronics in a very short time? Today we'll take around 20 minutes to assemble our first circuit, understand the different signals, how do devices really communicate with each other. They're obviously not talking in English, that we know. They're talking in Arabic, really, when you think about it. But we'll see how that works. How do we practice? So we'll practice a little on simulators. We'll see what simulators we'll be using through this entire track. And we'll see what we're going to be doing next in the next 2 sessions. And we'll say goodbye, but you'll know where to reach out to me later. That is awesome. I love people who have no clue about IoT and have no clue about what I'm talking about, because I can explain every bit in so much detail. That is great, Adarsh. Nothing. You have to download nothing, prepare nothing. We'll be starting right from scratch. You won't be downloading electronics. Well, you know what? Y'all can actually download the electronics. We will be using some simulators and it'll be fun, I promise. If it's not, just tell me and we'll, either slow it down or, I have a feeling today's space is going to be fairly good for everyone to, just have fun and get along. If you all don't feel like following hands on right away, that's okay. Take your time later and pester me on any other social media platform. I'll be happy to help you. All right, great. Let's move on. Answers. All right, folks. Hello, I'm Rithvi. If you all haven't attended, I just realized I haven't put my name on the slide, but my name's visible on the StreamYard screen, so that's good. I call myself a maker, as my background suggests. I have been working with a lot of random things lately. I'm freelancing currently with a couple of companies as a DevRel. So if you all aren't aware, developer relations is where you do engineering, you do marketing, you talk to people, and you're basically doing everything you can for the enterprise. I'm so glad you're excited to learn about electronics. Sure, my Twitter is what's flashing on the screen right beside my name at Frenzy30. That's my Twitter. All right. So I've been freelancing lately, which means I've been freelancing not just in electronics, but I've been taking up some art projects as well. So if you all see this nice cycle rim over here is for actually an art installation that I'm making. And just search for my name, Rithvi Mishra. You should be able to find me. If not, I'll share links with you in the end. All right. And I'm a coach in Major League Hacking. I'm going to complete 2 years in a month, which is very surreal for me because it feels like yesterday that I was doing my first stream, which was IoT Track 1. And yeah, so if you all want to tell me about yourself, go for it. It's 12:40 in my clock. We'll take until 12:43 and tell me what y'all are doing. You know, why are y'all here? Is there something specific y'all are looking for? I would love to see if I can incorporate anything in the stream today. I see so many people. I would love to know you all a little bit better. So we have 3 minutes, and it is more on-site based. So I don't do IoT freelancing as much as I do DevRel freelancing, if that makes sense. But yeah, so we have another 3 minutes, folks. Tell me about yourself. I really want to know. What about you? Are you all in college? Are you all in high school? Did you all just graduate? I graduated last year. I thought you all would be more excited to tell me about yourselves. No? No one wants to. Okay, that's fine. Oh, there we go. Oh, that is so good, Aryan. Congratulations on completing high school. Hi, Amit. Well, final year, I'm sure it's stressful. Best of luck. Another fresher. Well, not a fresher. I don't think it's a fresher. I forget the name that y'all are called. But y'all are freshers in college, right? So we'll go with fresher. But congratulations, folks, on completing and surviving high school. I hated my high school. So, oh, third year. Awesome. Stressful. All people I can imagine, except the people who are starting college who are probably enjoying right now. I can tell you all are working hard because you're here. But I think everyone's a little stressed. Final year. I hope you're having fun though. Final year can be fun if you know what you're on to. Awesome. Sophomore student. Second year, I think, is a weirdly anxious year where you're not really sure what's gonna happen next year because next year, things are supposed to get serious. But you can also chill a little and there won't be as many consequences. That is so cool. I love people who come from different backgrounds into computer science or into, engineering. I think y'all have a lot to contribute. That is a great question. Even though I have zero qualifications to answer that, I can definitely tell you what all I have been doing to make sure I stay in it. But I would really go to someone with more experience for that question. I'm happy to do that for you all. I can get someone senior to, come join one of these streams and help you answer these questions. I can imagine. That is so cool. I love people who work, for fun on electronics projects. They come up with some of the coolest stuff. That is amazing. Yes, Yash has very, made it very clear to me that I'm not really listening to you if you're teaching anything hardware. And yeah, well, anyway, but he's here. He's there for moral support for me at this point. All right, folks, let's move on. I am so glad to know each one of you all here. I might not remember specifically whether or not like you're in the second year or the third year, but I promise you I'll remember. Well, it's not really an exclusive inclusive thing. So robotics can have IoT can have actuators. So we'll bring up this question again later when I'm talking about components of IoT. I think I'll be able to explain better. But that's a great question, Aryan. Thank you so much. All right, folks. Like I told you, this is my favorite theme these days on Google. I just love the beautiful pictures they have of food. So we'll just keep seeing good fruits and food pictures as we go. All right, we are live. So let's make the most of us being live. All right, hi there, Jatin. Really nice to meet you. All right, right. So we're live. So we're gonna do something, right? We'll do what's IoT in a bit. But which device in your house do you think is actually using IoT? Right? Is part of an IoT network, right? You don't have to be correct. You don't even have to be, remotely anywhere near the actual definition. But go around the house, take a picture, and put it on Discord. All right, I will be watching the GHW chat channel. Uh, Join GHW. Wait, y'all don't have a GHW channel this time to chat? This is interesting. Give me 1 second, folks. Let me find the right channel for y'all to post this in. Folks, do you have a chat GHW channel or a GHW Hangout channel? Oh, it's called Season Launch. Got it. So go ahead, post your pictures in Season Launch. And until then, I'll find the channel for me. Season Launch. Yep. Thank you so much, whoever tagged me there. Thank you. Gosh. All right, folks. So y'all, that is a great example. Great example. Y'all don't have to be correct. Y'all just need to take a picture of whatever you think is an IoT device and post it in the Discord channel that's called Season Launch. We'll get to it. Random person. I love the username. So random person. We'll get to it. But go ahead, post a picture in the Discord channel Season Launch. If y'all can't find the channel, I couldn't for a bit. Let me know your Discord username. I'll tag you there. Hi Ayush. Well, I think YouTube is a great option too. In YouTube, you can go back and forth between the stream, so I can talk a little fast sometimes. So I think that helps. But Twitch does have a better chat interface, so I hope you can join from Twitch soon. Alright, so folks, I'm waiting for your pictures in Discord. Ooh, I love the first person who's put it, Paula. I'm not sure if that's how I pronounced it last time and that was correct, but I love the picture. Folks, come on. I am waiting for your pictures. As soon as I have at least 2-3 pictures. Okay, Ripslinger posted it. That is amazing. He posted a remote, and which is great because it is a smart TV remote. I can see that from the Netflix and the YouTube buttons on it. I can see a lot of people typing, so it's 12:48 in my clock. Let's give it time till 12:51, and then I'll share my screen. We'll go through all the pictures very quickly, and then actually move on to the definition. All right, no more people posting pictures. If y'all are posting pictures, give me a heads up so I'll wait. Otherwise, I'll quickly share my screen and we can move on. Oh no, I'm glad I could. I'm glad I could give a shout out. I share every chat that I reply to, and I reply to almost every chat, so it does get on screen. Okay, I see Yash having shared a ran. Oh, is that Iron Man from Endgame? Interesting picture, Yash. I like that. Okay, I love the smartwatch random person. And then there's Jatin who shared an amazing Ben 10. Oh, are you pointing to the watch that Ben 10 is wearing, or Ben is wearing rather? Discord link. Let me share you the channel Discord link. Give me 1 second. Copy link, and there you go, folks. I should have been doing this more. I don't know why do I go the complicated route. So this is the channel where you can share your pictures. Okay, I think I'll quickly stop sharing my slides and share the pictures you all have shared. Oh, I see Aditya shared Alexa. That is amazing. Sorry, मुझे वो नहीं मालूम. My device replied if you all heard it. We need to be careful when we take these names. This happened in my first stream too, which is just, I thought after that it never happened, so I assumed it got better, but it hasn't. All right, folks. I It's an Omnitrix smartwatch. Got it. All right, let me quickly share your amazing pictures onto my screen. I will definitely make a collage of this and send it to Mary for the GHW every day. She loves when you all do this. Share screen, Chrome tab, Discord. There we go. Mm. All right, folks. So y'all have been so amazing. One of y'all shared a laptop. Paul loved it. Great job. A smart remote. Amazing. Then Aditya thanked me for giving a shout out. And then yeah, shared the Iron Man doing, figuring out if time travel is possible. Then we have a smartwatch from random person. Still love the username. It's kind of genius. Then we have an Omnitrix watch that I'm going to be reading about today. Then we have this device, which I won't be naming. Yes, they absolutely do, but you don't need to know if it's an IoT device or not yet. You can just go ahead and share what you think might be an IoT device. Alright, folks, is there anyone else sharing or should we move on? Alright, I'm going to stop sharing my screen and go back to my slides because we do have a lot more to cover. But don't worry, we won't rush through anything. Worst case, we just, push it on to the next track part. Yeah, you all want to hear her tell me how she does not know what we're talking about. Awesome, folks. I think we made a great use of being live. If you all share any more pictures, I'm not looking at Discord actively, but if you all do, put it in the chat. I'll go back and see it. All right. Awesome, folks. Ah, mistake. But what is IoT? Okay, so this is not just a topic question, but consider this an intuition exercise. So this is what we do in my sessions, right? I'll ask you to tell me whatever you think it might mean to you. It has to not make sense. It does not have to, be correct in any way, right? For example, I asked people to tell me what they thought API meant, right? An application program interface. And one of my favorite examples that I cannot quote enough is this amazing hacker telling me how it's basically, them asking their siblings to fetch them stuff from the kitchen. That's an amazing example, right? But it was fairly correct, but it does not have to be. Whatever you think IoT means, I'll give you the full form. Do not give me full form in the chat. Internet of Things. All right, there's internet, there's things. What do you think it might mean? What's the first thing that comes to your head? It does not have to be correct. It's an intuition exercise to tell you that you already know the answer. We'll just, kind of thread it out to make it more sense to you, right? That is a great way of putting it. IoT is like Internet of Things, which makes a device able to process data like through internet. That's actually fairly accurate also. And very, very original. I've never heard that definition. They actually are. Wireless devices, printers can be IoT. Let me put it that way. Wireless printers can be IoT. Sensors that connecting to other devices. Great. I love the thought that you're forming there. That is another great way to put it, polka dot. So, robotics, that's the first thing that comes to your head. Instructions, great, great. We'll make that entire thought better and more clear as we go. But that's what you think, which is great. Uh, that is a great thought as well. Devices which can connect. Very intuitive, very correct. Uh, Hi, Nasar. Welcome to the stream. No, I'm glad. No, this is what I mean, right? The funnier you make it, the easier it's going to be for you to remember and form the thought. So go ahead, be ridiculous when you explain to me what it might mean. That is amazing. You even named some pretty great devices. Network of physical objects. I like the thought where you're headed. I'm listening to you all. I'm just gonna quickly turn on my fan, but keep the comments coming. We'll take another minute and then I'll dive into it. Mm. That is a great way to put it, Roshan. Like I like the vision that you have here. So you focus on making sure that you're building a drone that flies across the world, okay? When we start looking into solving problems. I promise I'll watch it. I do have time this week. I'll definitely watch it. Yes, they make your life easier. That's a great way to put it, Shiva. If it's not making your life easier, then probably go back to the old times, right? But I love the intuition you all have. You all are very, very correct in terms of the thought you all have. It's vague. It's great, right? The vague it is, the easier it is for me to kind of mold it into what it really should be. But I can be wrong too. So I love the intuition you all have. That's correct. This ad snippet, addy snippet. I'll figure it out at some point. But great job, folks. I love the thoughts that you have. Let's move on and look into what really is, right? So the definition of Internet of Things, very simply put, is human independent communication, right? How do you check if a system, let's say you all sent me so many pictures of the devices that you think are IoT, right? How many of those devices are capable of making human independent communication? They don't have to be making the human independent communication right now. Which is why when one of you all asked me whether a wireless printer is an IoT device, I said it can be an IoT device, right? It can communicate given the setup automatically without you interfering, and the entire system can take its own decision whether or not it needs to print something. Make sense? That is cool. I am very happy. I know you were gonna order stuff while you were in Pune as well. Precisely, right? They all have capability of becoming an IoT device, but are they currently an IoT device? Right? The point is you can control them remotely, right? That's the whole point. You don't have to. A IoT system has triggers, right? So that trigger can be anything. It can be you pushing that entire trigger, or it can be something which is based on a sensor, which is based on a actuator really, or an actuator feedback. So the point is the trigger starts an entire chain of communication that you don't have to really be involved in. If you do, you're kind of interfering. Precisely, using programming. That programming is actually has a name specifically when you're using it in IoT or embedded systems. All right, let me break it down for you, Polka Dot. Right, I'll actually be explaining the entire thing very soon. Right, so let's break it down. So hands on, we're saying that an IoT device or an IoT system has layers. Okay, ignore that for the time being. It has layers. Forget it. All right. It has components, right? It has next thing. It has its components. Layers is one thing. Then it has components. It has a hardware, right? That can be all the devices you sent me, uh, in a picture, or it can be you, uh, as a component of the system. It can be your microcontrollers. It can be anything that you want really to participate in the system, right? It has an RTOS. the code, right? Basically, the code that's helping the machines make decisions amongst themselves and communicate amongst themselves, right? There's human independent decision making because of the code, because of the triggers. There's always a trigger, right? There's always a trigger, and there's always an acknowledgement. The fact that there is a trigger and an acknowledgement itself makes it a human independent communication, right? What about a radio? Is it an antenna where it's connected to the internet? It still has its own communication channels to signal. How is the radio connected to the internet? Are you talking about a smart radio or something? Could you please elaborate on that? Polka dot doesn't make sense. I'll explain better with an example once we move on to components. Give me just 1 minute. Precisely. This is a great way to put it. So let me give you a very simple example. One of my favorite examples, really, is a smart bulb, right? The communication is very simple, right? You're either asking a specific device to turn it on, or you're literally asking, going on an application and pressing a button to turn it on. Now, it's a very simple system, right? It's you who's the trigger. So you're triggering the system, right? Then it's sending the to the cloud or wirelessly over your wireless direct, depending on the system you have set up, asking the bulb to turn on. Once the bulb is turned on, it knows whether or not it turned on, right? Based on that, it'll also give you a status whether or not it turned on. Makes sense? So even though it's a tiny chain, that tiny phone communicating with the bulb is the human independent communication that's happening, is what makes it an IoT system. Does that make sense, Polka Dot? I know, right? And y'all will always remember this slide because of that. This makes no sense, IoT and Raspberry. You know what? Now that I think about it, the raspberries do make a lot of sense, but I didn't mean it like that. But I hope that was. I don't see polka dot reply. Oh, you got it. Perfect. I'll keep explaining it as many times as you all like. Okay, so if it still does not make sense, do let me know. No, you know what? That's actually a good joke, but really Raspberry has more connotation with IoT. So I'm actually surprised how that worked out. That is an amazing question, Roshan. Keep that in mind. We'll cover that in a bit, right? Right. I'll make sure it's turned off for the next session, because this has never happened except the first session in which no one heard that happened. I know you asked this question before, Aryan. Yes, those are IoT if you're triggering it with your phone. If it's a sensor based communication, there's really no cloud involved. There's no wireless network involved. There's a sensor. It's asking the actuator to open. It opens. It's wired. It's really an embedded system. Yes, it's not IoT. But if you have it also connected to your phone and you can control it using your phone also, then yes, it becomes IoT. Make sense? Hi, RDX. Great to meet you too. It's not just about the action, it's about what's happening after that, right? There's one microcontroller, there's a sensor, and there's the actuator. Everything's connected to one unit, and they're just communicating. The board is the only thing that's really communicating with itself, right? Sensor and the door is connected to it, and it's really just an embedded system. It's like a washing machine, right? You have it running, it can do some smart stuff like have temperature sensors and make a lot of smart decisions itself, but it's really just an embedded system. However, if you put it on to the internet, which is on a Wi-Fi, and you control it using acknowledgements between devices, it becomes human independent communication. Does that make sense, Aryan? Yeah, basically it's only only one microcontroller is involved in the decision making, no inter-device communication happening. It can be the cloud. It does not have to be a cloud every time. It can be a direct wireless communication between two boards, between two devices that are capable of making decisions themselves. Correct. Well, I don't need you all to be accurate when you all are giving examples or breaking down examples, but yes, you're right about it, right? So a washing machine, which is a very smart washing machine in the sense that it can make a lot of decisions on its own, is just a smart washing machine, but not an IoT device. However, if it can be controlled, so all the devices that you are sent, right, like even that remote that you sent me, it can be an IoT device, given it, communicates. Now if you all are telling me that an IR is being used to communicate with the TV, there is no acknowledgement, right? Right, if you're pressing something from the remote, yes, it's wirelessly communicating, but the remote does not know if the, what it was supposed to do actually happened, right? It's not going to keep trying, or it won't tell you that, hey, the channel didn't really open, or the channel didn't really change. Does that make sense, folks, why the acknowledgement part is important? That's okay, Nasari. I'm glad. I really appreciate the effort to try and joining, that you tried to join. So are IoT devices slightly less secure than those that are absolutely? So how are you defining security? Like, you're adding an entire new layer of communication. Every layer of communication comes with its own security issues, right? It's like anything you put on the internet, it can be hacked into, right? So you make your entire layer secure. You encrypt the information you send over the network layer. The moment you join any network, there's a whole new, lot of security issues that exist, which is why, of course, if you see, the more of the greater person wants to go, the lesser smarter devices they'll have that are not capable of joining any network, forget whether or not they can, right? Absolutely. So, what an acknowledgement is, it's a great question, by the way. I can tend, so I don't know how much you all know, how much you all are understanding. So, when you'll ask these questions, it helps me, break down my information better. So, your smart bulb, right? You asked it to turn on, and your app can now tell whether or not it was turned on. So, when the bulb turned on, the system or the chip inside it sent an acknowledgement saying, okay, it's like an HTTP code, right? You get an okay, great, this worked, or an error code that, hey, this did not work. Then there's something called a timeout, where your initial device that you send the information from will try it a number of times, or until wait for an acknowledgement. If there's no acknowledgement, also, for example, right, if the device is turned off, there won't be any acknowledgement, right? If it receives no acknowledgement, it will tell you that, hey, the device is turned off, I can't reach the device. That is an acknowledgement. Does that make sense? Dreaming godball. One word application of IoT. Do you want examples of IoT? Yes, an automated vehicle that you're controlling with your phone, that you can see stuff on the phone, that you can control the lights and the temperature and AC, everything from the phone, or any other device really, which can tell you whether or not it happened, right? So a remote, yes, you can control, but does the remote know what happened? No. But if a phone or any other device that can tell you that, hey, this did not work, or it did work, and can tell you the exact status of the other device, then yes, it's an IoT system. I love the excuses you all are making. That tells me how creative you all are. But I hope Nisarg left and is attending the lecture. I hope the yes is for my explanation and not the excuses. I can never tell with you all. But okay, great. Are we all on the same page, everyone? Is there anyone who has any question about the basic definition of IoT? Any weird words that I use, like RTOS, embedded system? I promise I'll cover them in detail as we go. Sure. So let's say your smart home device. I'm not going to take the name, but the smart home device, you asked it to turn on the light. Or let me see if I can think of a better example. Hmm. Oh yeah. So you know how your smart home systems have this thing where you can schedule. Uh, if it's light, turn off the lights, or open the curtains. If it's dark, close the curtains. You can basically automate everything. That's a great example of the triggers and acknowledgement. So your smart home will have triggers. Now the trigger can be an actual sensor which is measuring light, or it can be the cloud or the internet data of, okay, it's 4 a.m. The sunlight's here, the sun's here, and it's, this is what the status is in this city, and it will, that's the trigger. That information is the trigger, and based on that, it's gonna, either turn off the lights, turn on your lights, open your curtains, basically whatever you have automated turn off the AC, turn on the AC, anything that you've automated and put on the system, on the network, will get triggered. Make sense? Adi snippet. I like the scaling Jedua is doing for your excuses. I like how your excuses are scalable as well. I know. Don't worry. I'm glad. Yes, if they can be, so for example, right, your smart home devices which are also speakers, you all can, trigger them to play music when it's, as an alarm, right? So let's say tell it 7 a.m., play the alarm. 7 a.m., if it's a clock, it's going to be a different kind of inter-system, but you get the point, right? Yes, your Bluetooth system can be a part of the IoT device given how they're connected to the network. If they do have the capability of connecting to a network, however, they're already, an IoT device. Hmm. Well, no, it isn't, because it is still capable of being an IoT device and part of an IoT system. It alone is, an IoT component. It's not IoT just yet. It is communicating to the internet, yes. But you know what? Actually, I'll give it. It is an IoT device because it is communicating to the internet, and it does give you an acknowledgement when it does not get a response from the internet, right? So yes, it is alone also an IoT device to some extent. It is communicating with the cloud, and it is trying to fetch you information, because that is how communication happens, right? If we're saying human independent communication, that means there has to be a trigger where the communication starts, and a communication, for it to end, there has to be some form of, okay, now the communication's over. Makes sense? Otherwise it's not really communication, right? It's basically a trigger. Precisely. It's not just a response to a trigger. It's a response whether or not the response to the trigger was successful or not. Makes sense? Precisely. So when we start looking into protocols tomorrow, you'll understand how acknowledgements are a huge part of any protocol that we use, and a huge part of security also in those protocols. Right? Smart speaker, because I'm assuming they have more capabilities than just streaming music over Bluetooth. Bluetooth speakers alone, from what I understand, can only stream music. But here's the thing: you have a lot of circuits, I2S circuits, which you can connect to the Bluetooth speaker, and make them respond to the trigger easily. So it's really say and tell. It's really it depends on the system, which is why I said that an IoT, you cannot tell whether the device is IoT. You can tell whether or not it's capable of being IoT, and second, you can tell whether or not it is IoT based on the system it's participating in. Precisely. That's literally how your network layer works also, right? Your HTTPS layer. So that's precisely how it works. And so even the S part in your HTTP, basically sending an encryption key, is how your protocols in IoT work, right? So if you understand the network there well, you basically have a very good hang of what we're going to be doing. It's just tiny things based on the device constraints that'll change. You know what? That's a great question. This one. That's a great question, and I usually love showing off my devices. But my room's not really in a this part especially is not really in a state to be showed off. However, tomorrow I'll clear it up for you all. I'll keep a nice range of IoT devices and a separate camera for you all to have it streaming all along if you all want to keep looking at. I have a lot of boards that are capable of being IoT devices. Precisely, handshake. That's another very important word that we'll be, looking into. You all want to see her? I can show it to you. There you go. There she is. I showed you. Okay, folks, let's move on. Right, let's move on. All right, so this is for you all to help visualize the entire thing better. Right, so this is how a network or an entire system would look like. So you all have sensors, devices, things that can be anything, right? It can be your application on your phone, it can be a sensor, it can give feedback from an actuator. What do I mean by a feedback from an actuator? It can be, a motor running and you're measuring the speed at which it's running. So let's say you have a cycle, right? And you're cycling and you're measuring how fast you're cycling, and based on that, there'll be certain triggers, right? So a trigger can be anything, but it's basically your things, right? The things are connected to the network. The network helps you connect to the servers or the cloud. Now this entire thing is a flat visualization, right? And then you have your applications that are being triggered. Over here, your server, the cloud would be your Amazon cloud, your application would be the bulb, and then your devices, which are all communicating to each other. The server, the cloud can also be a simple router that you're using to, use the entire system on one network, not particularly the internet. Fair? I like how you all are so hung up on the smart home device that I have. What does the server do? The server basically helps you cache your requests. For example, now the smart home device and bulb example is a fairly simple one, right? But where is the request that you're making going? From the application. It's not going to the bulb directly, right? Until and unless your application is not on the same network, that means your phone is not on the same Wi-Fi direct, or the same Bluetooth network. It's not going to the chip directly, right? It's going to some cloud which is connected to the internet, to which also your bulb is connected, preferably by Wi-Fi, is how it's triggering. So the cloud is really just sending the data. Now the server or the cloud does not always exist. If you're on the same network, you can be directly communicating to the next device. The device itself can act like a server, do the decision making, and then run. Makes sense? Polkadot. I love how you all are so hung up there. Perfect. I'm glad Polkadot you got it. Basically, that's the classic definition of server. But in IoT, it can basically be anything that caches your information. Mm. I love the dedication you all have to, getting Nisarg out of the class. Forget the IoT session. Alright, folks. But like I said, this is a flat visualization, right? This can work in any way. Your entire device can be the gateway, your controller, which is also a thing, can be, the decision maker, your sensor can. So sensor will always be a trigger, really. But you all get the point, right? That was a flat visualization. Your entire device over here, a network device, it can be a network of network devices, right? So you could have like a small system, for example, in one room, right? Then there's another system in one room, and they can communicate amongst themselves over the cloud, which becomes, like a internet of things, right? So it that's not IoT. That is not what we're going to be talking about, but you get the point, right? Hi, Pradupna. Welcome to the session. All right, folks, let's move on. If you all have any questions regarding components and hierarchy, still keep them coming. I'll explain as we go. All right. All right, looking forward. So that's a attempt at pun that I made, because firmware forward. Anyway, uh, these are all the words that we'll be hearing a lot. That is true, Polar Void, and welcomes to the session. I haven't seen you active in the Discord server or hackathons in a long time, Alvin. I'm so glad you're back. All right. So let's look at a lot of words, right? So there's RTOS, there's firmware, there's device architecture, there's components, there's an embedded system, there's a not a GPOS, and then there's a cloud, right? So many words that I've used. I'm sure, I know some of you all have asked questions on that as well. Okay, so let's start with something simple, right? Questions. So let's make sentences out of these so many random words, and in the end create a one paragraph that explains all of it easily, and for you all to remember rather easily. All right, so let's start with RTOS. What's RTOS? RTOS stands for Real Time Operating System. Now it makes me realize I should have got it on the PPT. I really don't. So I'm just going to type it out for y'all in the chat, right? So it's called a Real Time Operating System. Right? That's RTOS. Okay? And oh, hi there, Kagayo. Right, so it's got a real-time operating system. Why an RTOS? Why not? Why? What's the difference between RTOS? So just so you all know what your normal OS is, your computer OS is called a GPOS. It's a general purpose operating system, right? Anyone want to give me a, take a venture at it, right? It's 1:19 in my clock. I'm going to give you all until 1:22. What might be the difference between a real-time operating system and a GPOS? It is better than fake time. Basically, it's much better than fake time. Yes, you want. Why do you need real time? That is, I don't think so. Airlines reservation system, RTOS. Are you all sure? I have not heard of this. This is new information to me, but I will definitely look it up. That is a great answer, Polka Dot. Yes, RTOS works on its own, and a GPOS is more user based. That's actually a much better definition than I would have come up with in one line anyway. Calculate real things, real time. Yes, that's an important thing for it to have a sense of real time. Great job, Shivam. Polka Dot and Shivam did a great job explaining it. So if you all still have, ventures into the definition, keep them coming. But I'm going to tell you the real definition, right? So, like Polka Dot mentioned, RTOS works on its own. Which, what that basically means is there is a setup code, right? Now that setup code is called a lot of things in different, versions and what you're basically using in terms of flavor. But it's basically a setup code that runs once, right? It's like your when you run your normal code also, right? There's a setup code, then there's the main code which you keep running, or you go through until your entire logic is over, right? So the same thing happens, right? There's the setup code that runs once, and then there's the code that keeps running. What do you mean by keeps running? So let's take our washing machine again, right? A washing machine has an RTOS. What that means, it has specifically designed functions, right? When you press this button, this is the function it takes, and this is how much it does. It does that thing for 20 minutes, so it has a very good count of real time, a very good sense of real time, right? And it'll do that cycle for 20 minutes, move on to the spinner cycle for 20 minutes, and so on and so forth, right? So it's a very simple thing. That's all it's going to do. It's not going to see you walk into the towards the washing machine and go, no, I'm gonna run for 30 minutes today. It won't do that, right? Or it won't stop if you're nearby. I mean, given sensors, of course, but that's not its program, right? Basically, it's going to do what it's asked to do over and over again. There's no, if you press the button, in a certain way, it's going to get angry and it's going to, be like, I'm going to run for 10 minutes only today. Right? So it's got a sense of real time, and it has a specific function. So it's going to keep doing over and over again. So every time you turn on the machine, it goes into a menu, it runs the setup code once, sets everything up for you, then it's in a loop, right? Now you press the buttons, you start it, it's going to do the same thing and go back to its original state. That's an RTOS. A GPOS is more user based, which means if I click here, it's going to get clicked there. If I select something, it's going to select it. It has no clue what I'm going to ask it to do next, right? But it's prepared. And if it's not, it hangs. So that's a GPOS. Make sense, everyone? Polka dot, does that make sense? I love how happy you are about it. It's 1 a.m., but I appreciate you turning up to the session nonetheless. I sure will. The slides are very useless because I'm using them more as flashcards for me, but I'm happy to share the link with you all. You know what? Let me do that. I'll do that after the session. Airline reservation systems use RTOS? Are you talking about like the physical systems that they use? Or are you talking about the online websites? Because I'm very confused. Uh, Sounds good, Polkadot. Let me elaborate a little bit more. It's a good question. It's basically like asking me whether a device is IoT or not, right? If a system is an embedded systems, given the right capabilities, it can be part of IoT. But they're not exclusive, or they're not mutually exclusive like that. Make sense? Mm. Washing machine, microwave, your refrigerator. It has a hardware that's running certain code for decision making, and it is very simple. You know temperature control in your refrigerator, not the smart refrigerators that you can control with your phones, but to some extent them also, right? They're all running RTOS, right? Because they have a simple task. They're just keeping the thing. As soon as you change the temperature, it's gonna go tell the chip, okay, change the temperature, and the temperature changes. Does that make sense, Dreaming Godball? The airline reservation systems, is that what you're talking about, Alvin? Yeah, I doubt they would use RTOS, really. It seems a little stringent to use RTOS for something so, important. Okay, folks. Okay. Industrial control systems, real time. One is I don't understand. If you, oh yeah, you're trying to tell me the definition exactly. That's the exact definition. Then yes, a lot of protocols come under IoT. So Bluetooth to some extent is a protocol. It's also a connection method. There's MQTT. There's XB. And a couple of more we'll be covering. CoAP. A couple of more that we'll be covering tomorrow. So this is a great example or a great definition that Vandit has put, right? So RTOS is used everywhere if it's a embedded system almost. Refrigerator and microwave, even your smart lights are a good example. The thing that Vandit has put is the industrial IoT or the industrial use of RTOS, which has a slightly different requirement. So there's something called soft RTOS and hard RTOS, right? A hard RTOS is basically super accurate. For it, the priority is to get the task started and done in time rather than the decision making. It has a more trigger versus action orientation than okay, should I do this, should I do that, maybe not, right? A smart light, if it turns on 3 seconds later, that's okay. But an aircraft emergency system, if it's not absolutely to the point and it does not react immediately, then there's going to be some problem, right? Entire your car automation systems, right? If they don't trigger immediately, your airbag system, if they don't trigger immediately, it's a huge hazard, right? But a smart light, 3 seconds, 4 seconds, it does not turn on in the first go, that's okay, you just ask it for it, you won't even give it a second thought, right? No, I'll definitely Google it, Pradhan. I'm very intrigued by the thought of airline reservation systems making use of an RTOS. But I'll definitely look into it. I think that would be very cool though when I think about it. Treadmill, yes, treadmill also. Any of your devices, embedded systems, right? Even your smart TV for that matter, right? Mm, It is not a subset of GPOS as much as it's really a very different purpose OS, right? So your Android phone for that matter, right? That's a very weird thing. What would you qualify it as? It is fairly user based, yes, but it's still to some extent an RTOS. And the best way to, make sure that that's what it is to look back at its history. If you all don't know, Android was actually created for a camera, right? And a camera is supposed to do some very specific things, right? So an Android OS is actually, an evolution of an RTOS. So you can't, again, they're not okay, our GPS can do this and RTOS can do this, so they're different or the same. And RTOS has a very different purpose of existing, let alone being compared or derived from something. Does that make sense, Amit? I hope you had too, but that's okay. If you all have to run, that's fine. But I'll definitely look into the airline reservation system. I'm glad you understood it, Amit. Right? So let's move on to the definition of. Oh no, we're left with a lot of things here. I do want to cover them, but we all want to maybe get started with some of the hands-on part. We'll just take a breather if you all want very quickly for 5 minutes, and then I suggest we start with the hands-on part because I think it's getting a little slow, right? And then we'll come back and cover some of the theoretical topics because I feel there's been a lot of information overload on you all right now. Yes, do you all have a preference? We'll come look at IoT versus IoT in a bit because it's not really, yeah, you won't screw up, right? So let's look into electronics and let's look into simulators. Yeah, so I'm going to leave us on this slide. you all should look up, start opening Tinkercad and Wokwi. But we'll take a quick 5 minute breather here. Yeah, so if you all want to quickly grab some water, I'm going to be doing that. And we'll meet back here in 5 minutes. It's 1:28 on my clock. We'll see here 1:35. I'll cover it, I promise. But let's get a little hands on because I feel it's getting a little slow and very, very information heavy. Awesome, folks. I shall see you in around 5 minutes. No, you all don't have to download anything. Alright? Yeah, I'm gonna take it. Alright, folks. I hope you all are a little better in terms of the information that was literally bombarded upon you is slightly smoothing out a little. And I shared the slides with y'all. I did give y'all a little bit of music. It was a tad bit late, but you got it. And yeah, awesome. So are we ready to go, folks, or do you all need another minute? I'm glad you love it, Aryan. All right, folks, let's move on. I hope you all have opened your simulators. If not, that's okay. I'll be sharing a link in just a minute. Let me stop sharing the slides. That is all for slides. We'll just go over, all those words mentioned a little more as we go. Today we'll be making a couple of small circuits, and then I'll be showing you a code, right? So we'll make two small circuits, one digital, one analog, one digital output, one analog output. Understand what's happening in terms of communication, right? So there is the internet communication, that's the high level thing, right? I told you there are layers in IoT as well. So we'll talk about all of that tomorrow, right? Forget there's internet right now. We're gonna look into it right now into one single device, right? So let's say it's a remote. You press it, it sends an IR thing with an information. That's one of the simplest circuits that I can explain, which is why I picked up, right? Anything else would require a lot of, multiple things are happening there, or multiple scheduling is happening there. So let's just stick to a remote. All right, we'll look into what do you mean by analog reading, analog writing, digital writing. We will take up a random template from the same Tinkercad. You don't have to write any code today. We'll read it. We'll read it and we'll comment what's happening. All right, because the thing is, Arduino code is what we'll be looking into today, and it's very abstract. What do I mean by it's very abstract? Is that there are so many libraries, so many nested libraries that are being used. That there's one library, that library is calling that the next library, and then the actual hardware communication with the code is happening on the fifth or the sixth level, right? So we'll also look into that a little bit. So we'll break down a library at some point, either in the next session or the session after that. But today it's going to be very simple. You just need to get very comfortable with the words like analog write, analog read. Why am I asking you to do an analog read and not a digital read? If you all have attended the electronic session, you all already have a good idea, but you all can help the people who do not know if you already know, right? So simple stuff, right? Tinkercad is very fun to play with. It's very graphic, so I am sure you all will have fun. Let me quickly share the link to Tinkercad in case you all did not find it. There you go. Thank you, Pradumna. Yes, I worked very hard to get all of this here. And right now, my favorite thing is the cycle rim there. I hope I can show you all what I end up making with it by tomorrow or day after session. Alright, folks. Tinkercad link has been sent. And Wokwe is something we'll look into a little later because it's slightly, again, higher level. We don't really need to look into it right away. Okay, so we'll spend the next 20 minutes just building some circuits, understanding analog, digital analog. Then we look at an example code. You'll have to do nothing but open an example. We'll read it, comment on it for better understanding of ourselves. Again, it's a very optional thing. If I, for that matter, encourage not notes taking because I think you all pay more attention then, but personal preferences, right? Perfect. So this is where we are heading right now. Let me present my screen. Share screen, Tinkercad dashboard, and that's my dashboard. All right, let me click on create a new circuit. If you all are here, I haven't added to my screen, have I? I like to call it a makerspace or to be makerspace anyway. But look who's back after such a long time. Shrikaran, there are none of your fans who are left here. So I feel so much less insecure of you being here. Alright folks, let's go into Tinkercad. Let's create a new circuit. Alright, so let's start with something very simple, right? So I'm going to take an Arduino Uno. Now remember, Arduino Uno itself has no way to communicate wirelessly, right? What you can do is you can add a Bluetooth module or a Wi-Fi module to make it communicate. It in itself is fairly dumb. Alright, so let's go ahead. and add the Uno. Yay, right? Okay, so there's a lot of things I want to talk about the Uno. So I'm going to give you an overview. If you understand, great. If not, I promise I'll keep repeating these things. So don't worry about it. Okay. The thing is, if I keep diving into each thing, because then it'll become like an electronics track and not an IoT track. Okay. So okay, your microcontroller is this tiny black thing right here. Okay, this is an evaluation kit. What is the difference? Well, a microcontroller has a lot of capabilities, right? But it requires a lot of components to draw out that capabilities. Just remember what I'm saying if you can. You all don't have to understand it down to the T. All right. So a microcontroller can do a lot of things like understand multiple signals, read a lot of signals, write a lot of signals, but not on its own. It usually requires help of voltage regulators, resistors, sometimes capacitors, uh, MOSFETs for switching, right? So it requires a lot of components. The thing is, if you're starting out, or let's say, I come to you and I'm like, hey, here's a new microcontroller that I made. Would you like to use it? You tell me that, hey, I can't spend time designing, the only, designing basic stuff to just use the microcontroller, right? You'll ask me to give you an evaluation kit, which means I'll select some of the key capabilities of that microcontroller, draw it out into an evaluation kit, which is basically, give you these pins, a button, maybe even an LED. All of this is like a board designed, RX lights to tell you whether or not receiving and transmission is happening. There's a voltage regulator here, there's a MOSFET here. So there's a lot of things on the board, right? That's not part of the microcontroller. This tiny thing is the only microcontroller. But Arduino said, all right, you know what, if you want to use the Atmega chip, which is fairly difficult to use if you're starting out, understanding so many things, understanding the power sockets and the calculations behind it, we'll make it easier for you. You just give it USB power, so it added the USB also on the board, and it told, okay, you can do these many things. The chip itself is capable of a lot more. Remember that in Atmega chip you can use it for a lot more, but it's given these specific capabilities for you to try out and make simpler circuits. Now, if you take this entire, so let's say you make a project with it, right? You add a sensor, you add an actuator, and it works well. Now, you can't make that into a product, right? It's going to look, well, forget look, it's going to be very bad in terms of efficiency, because the other things that have been pulled out for you to try are still going to be using some sort of power, some sort of, efficiency bandwidth, right? It could be heating, it could be just, obscuring or obstructing a certain pin, right? So when you'll actually make the product, you'll only take the tiny chip and design your own board around it and only pull out stuff that you actually need. Let's say it's a button and an LED turning on. You'll only use the button and an LED pin and whatever other logic that you want to write into the code. And only that will work, right? Also, uploading code onto an Atmega chip can be fairly difficult because you need multiple different routes to do that, and the code is a little more different, right? So what Arduino has done, it's abstracted the code. I explained what abstracted code is a little bit ago. It's abstracted the code to this extent that you don't have to think twice. It's basically English. You write it, you click one button, and it gets uploaded onto the controller. All right, let's see what you all have been chatting about in the chat. Well, I won't comment on that just yet. Yep, the USB controller too. That's right. Okay, so Arduino to some extent is an evaluation board. It's basically, a development kit. So either an evaluation kit or a development kit. That's the more accurate word for Arduino. Uh, I like how you all are having fun, and I have no clue if you all are actually listening to me, but no, you don't have to draw it from the scratch. There's literally a drag and drop right there. So just pick the Uno and get it to the center, and you'll be good. Thank you, Alvin. This is an Atmega 328P chip, and when we go over the data sheet tomorrow, which is not as much fun as it is to describe, it is definitely very important because I'll be talking about a lot of signals today, and to be able to tell which chip can take which signal and what circuits you need to add for it to be able to process those signals is where you learn from. So Folks, are we all on the same page? Give me that is an excellent idea, Alvin. The thing is, with the universal, use of data sheets, I think we'll have to be very careful culturally, language wise, and diversity wise that it will no longer remain a meme. So, references also for that matter. A chip does basically what the data sheet of the chip says. A chip can, read signals, has a lot of logic, you put code onto it. So the code is basically your final code that you're uploading is running here. This is the brain of your entire kit, right? And it does multiple things. I'm sorry, the thing is I can get into it in depth using the data sheet, but I don't want to go down that lane. I want you all to be able to construct your own circuits, understand the basics of what this development kit is capable of doing, not the chip alone. And yes, you know what? We'll do that. We'll have an MLH data sheet of Arduino and we'll add memes to it. Yeah. Yeah, well, we won't again, not programming per se as much as understanding the code. Yeah. All right, folks. So this is an Uno. You see a lot of fun they've had. They've randomly put tildes in front of numbers. They've randomly gone from 1 2 3 4 to A01, A0 A1, and they have a lot of numbers and with the word V in it. Right. What are all these? Right. I did not. Please do send me a link. This sounds interesting for sure. All right, folks, right? So, what are these things, right? So, I again won't go into a lot of detail, but all you need to remember is these are your voltage chips, right? Any sensor or any device or actuator that you connect to a board needs power, right? It needs some sort of powering. You can't always connect, you can't have five sensors on your board and all five of them connected to USBs, right? So they draw power from the board, right? So these pins, the 3.3 volt, 5 volt ground, and VN basically help you give and get power to your sensors, right? Then comes the A prefixed pins. These pins are analog pins, which means that they can read analog. All right, make sense, folks? Let me know if I'm going too fast, okay? These pins give power to your sensors and the components connected. You can chain your components here. I'll show you what that means. And then these pins can read analog. I'll get into what do I mean by analog and digital in just a minute, but I need you all to give me a heads up that, okay, A0 pins, A1, A prefix pins are reading analog. Okay, I'm a little concerned about the silence here. You all want me to repeat it? Does that would an example make more sense? Okay, perfect. I thank you, Pravar, for agreeing. What is the name of the whole shape? It's called an Arduino Uno, right here. Arduino Uno R3. That's the name of the development kit that we're using. Alvin says it makes sense. What does each square mean? That's a great question, Polkadot. So each square, this square is basically where you connect pins to, right? This is where you'll connect your components to, right? We'll be using them in less than a minute if I'm sure you all are on the same page, right? So remember your A prefixed pins can read analog. So it over here you can see it also says analog in, right? So there's power here, analog in here. Then these are what the Uno calls digital pins, and then it also has something called PWM, right? So digital pins obviously can read and write digital. The PWM pins in particular can give you, or rather can pretend to write analog and pretend to be analog by using something called pulse width modulation. Okay, don't worry too much about the words you all don't know. I will go over each one of them in just a minute, but I just need you all to understand, okay, these are digital pins, they do something called PWM. That's all I need you all to understand. Okay, if you all understand or are on the same page. Hi there, Gaming Skull. Welcome back. It's been a while. I'm doing great. And I think we're having a lot of fun too. And we're running really behind schedule, but we're having a lot of fun, hopefully. Right? Awesome, polka dot. Let's move on, right? So now I want to quickly go over signals, right? Okay. How do devices communicate? Right? They're obviously not speaking English. They're communicating in voltages, right? So absolutely, Ali Snippet. You can do it whenever you're comfortable. It's okay if the phone is straining your eyes. You can just join it later. Okay, don't worry about it too much. I love your when you all interact. So if you all want to stick around for the interaction, that's great. But otherwise, if it makes more sense to do it later, do it later. All right. All right. So you all know that devices communicate using voltages, right? So what's the difference between a digital? What do you mean by digital voltage versus an analog voltage? So I'm going to quit sharing my Tinkercad screen for a minute, and I'm going to share a really ugly Jamboard. Well, I'll share a Jamboard. We'll make it really ugly when I start writing on it, right? So let me quickly open a new Jamboard. Jamboard. Okay, while it opens, I'm going to quit sharing the screen. That is very cool. I did not know digital fans in the PC used PWM. But I have a gaming laptop, so I'm guessing I'll have a lot to look into. All right, stop screen, present, share screen, untitled Jamboard. Great. All right, let's put it IoT track one. If I want this Jamboard, I'll share it, but it's fairly useless, just as a heads up. Okay. Okay. So we know that voltages is what the language is used by microcontrollers and just generally everything electronics to communicate, right? So what is a voltage? So you all remember when we looked at the power circuit of oh, don't worry about it, Kagayo. I appreciate the questions. If anything, you asking the questions is helping a lot of people here who are here new as well. So that is a great answer. 0 and 1 is what I'm going to stick to. The rest of it is fairly complicated. Like, I understand where you're coming from, but we don't really need to look at the part. But yeah, 0, 1 is what we're looking at. So a digital signal has only two states, 0 and 1. An analog, however, has multiple states, right? Remember, it's a sine wave. So how does a controller differentiate between a 0 and 1 and an analog signal? So our controller is 5 volts. All right. You can tell I'm very good practice with this, right? So let's draw a 5-volt signal, right? So this is 0 and then this is 5 volts, right? It's a DC voltage, okay? So this is the 5 volts, this is 0, this is supposed to be straight in case you all are wondering. This is curved by mistake, but it's supposed to be very straight, okay? So that's your 5-volt signal, right? That's what is being fed. Now that is what your controller knows, right? Now your sensor comes in, right? Now this is your sensor, okay? It wants to give your controller an analog signal, right? How will it tell the controller that it's giving? So let's say this is the analog signal it's generating, right? So, right, this is the analog signal it's given your controller. Remember, this is your 0 line. It won't give it a negative. This is your 0 line, and this is say your 5-volt barrier, right? So how does your controller know what to read when this is coming? At this point, at this point. Here's what happens, right? There's something called a circuit which is externally connected. It's called a ADC, analog to digital converter, which basically means we're taking an analog signal, converting it into digital numbers, or rather digital readable format, and then giving it to the controller, right? How does that work? No, it's not. That's what I'm telling you. We do not have negative here. I usually draw the line for symmetry. You have a 0. Your controller voltages will always start from 0 to whatever number. It can be a 5-volt controller, a 3.3-volt controller, and so on and so forth, right? Make sense, polka dot? A sine wave, precisely. To basically, let me just make it for you again. All right, so over here, this is your sensor line, and let's say your sensor is giving this signal. But you can tell it gets very bad. So this is 0 and this is 5. Make sense? How do you mean it can't be zero? Technically can't be zero. So you have voltage, right? Alvin, this graph isn't numbers. It is the voltage that the sensor is giving you. It can't give negative voltage. Does that make sense, Alvin? It does not make sense, Gaming Skull? Perfect. Good. Precisely. That zero is a very important value for that matter, right? Because it is basically another state in a certain communication type. Oh, like that. Okay, so you're talking about the reference voltage. Yes, Gaming Skull. That is actually a very good point. So this is something slightly more of a complex concept, or rather even an advanced concept in terms is, let's say you have five sensors, or rather five different components connected to one microcontroller, right? Now there's a high chance all their reference voltages might be different, especially let's say I connected, if you don't connect all the grounds, right? So if I let's say I have one microcontroller connected to one sensor, and then somehow I've connected that sensor, chained this sensor, and have another controller here which has basically another source of power, right? If you do not connect all the grounds, if you do not connect all the grounds, the reference voltages can be different. If the reference voltages are different, for example, you have a 3.3 volt controller and a 5 volt controller, you're somehow chaining, a sensor between them. If you don't connect the grounds, let's say you have grounds connected here, grounds connected here, and then let's say you're connecting an NRF together. If you don't have all the grounds connected, the reference voltages can be different. And yes, in that case, there can be a lot of gibberish that the controller reads, which again, you cannot have minus numbers, but it will be numbers that it does not understand. And depending on the bit, the if it's a 32-bit controller, if it's a 8-bit controller or whatever, the numbers will basically repeat. There'll never be signed integers, if that makes sense. That's awesome, Adi Snippet. Does that make sense, Gaming Skull? It'll never go below zero. Okay, I know that's a slightly advanced concept. I cannot think of a better example to give you than chaining sensors. If you'll ever do a lab, or if you can ever look into an electronics lab, a lot of times we use a lot of scopes, and you want to chain all the scopes to ground, otherwise you never get the right signal length. I wish I had an example right now, but I'll try and find a video for you all to see tomorrow. Regardless, that's not the point, right? So you know that this is a 5 volt signal, right? The controller can't read this. There's something called an ADC, right? And an ADC has a magnitude. Okay, what is an ADC magnitude? An ADC magnitude decides whether or not, or rather how much of a accurate result that a microcontroller can give. So let's say my sensor is giving me, a very good value, right? It is very sensitive. It changes its, output, or rather the graph value, very quickly on change, right? But if my microcontroller cannot read that much change, right, it is the one that can decide how much of the change it can read. Even if this is changing for like every, 1/100th of a Celsius, my controller won't be able to detect that. It will only detect if there's the change that is in its magnitude. What is the magnitude? For example, your Arduino has an 8-bit or a 10-bit ADC, right? So it has a 10-bit ADC. What is a 10-bit ADC? So how do you decide an ADC ka magnitude? It has a 10-bit ADC, which means 2 to the power of its magnitude is the range of it. Okay, let's break that down. So I said 10-bit ADC, so 2 to the power 10. Can someone tell me what's 2 to the power 10? Oh, I see what you mean, Gaming Skull. I'll get to it. I get what you're saying now, and we'll get to it when we study digital signals. I just want to get over the analog part because it can be a little tricky, and I need you all to concentrate, right? Precisely 1024, right? That's 2 to the power 10. That's your magnitude of the ADC, right? So now this 10-bit ADC is the change it will say. So doesn't matter whether your entire signal is like has like 5,000 changes. It has 5,000 counts of changes. So, for every 100 of the Celsius, it goes up 2 counts and it has total 5,000 counts. Your ADC will be only able to detect 1024, which is 0 to 1023. So even if say so 5,000 divided by 1024 is the amount of change it will be able to detect, right? So let's take 5,024 and let's go, or rather take 5 times, right? So even though the sensor has a sensitivity of 5,000 and basically 1024 into 5, for every 5 changes, or rather 5 counts of changes, is when your controller will be able to tell, okay, it changed, or this is the new signal. Makes sense, folks? Do you want me to explain it again? So what will happen, what's basically happening is this entire graph, it doesn't matter how accurate or how smooth this graph is, this entire thing the controller is going to divide into 1024, starting with 0 to 1023. Why am I telling you this? Basically, now if you connect an analog sensor, right, let's say you take a temperature sensor, right, what you will do is you will map it, right, based on the range that you have. So let's say the sensor has a range value of, it can read from say uh, 0 to 50 degrees Celsius. You will break it down. So you'll map it 0 to 50, map it to 0 to 1023. So if the temperature goes beyond 50, it'll keep showing 50. Makes sense? If it goes beyond below 0, that's all the sensor can read. But between 0 to 50, even if it can measure like a tinier or like a 6 decimal unit, you won't be able to see that because your microcontroller can only read 1024 values. No worries, Aryan. I'll just start over. Okay. I'm going to take a new page. I know how to open a new page. There we go. Right. Okay. This is your analog signal, right? This can be anything, right? Remember, your sensor voltage is the upper limit of its signal, or signal can be lower for that matter. So your sensor can be connected to a 5-volt power, but it can be giving a 3.3 volt sensor. So its highest will be 3.3 volts, right? In that case, your 3.3 will be divided by 1024, in which case the thing will get more accurate, right? Rather than 5 divided by 1024. So 1024. Now, this value, 5 divided by 1024, is the change that your microcontroller will be able to read. So every time the sensor moves up or down by 5 volts divided by 1024 is the voltage value it will be able to measure. Does that make sense, Alvin? And in terms of calculation, folks, the mic ADC value of Arduino is 10 bits, which means that it can measure, it has a sensitivity of 2 to the power 10. So voltage divided by 2 to the power 10, which is your microcontroller is 5 volts, and it can its detection sensitivity is 5 volts divided by 1024. So for any voltage that is 5 divided by 1024, it will be able to tell that, hey, the voltage changed. If it's lesser than that, if the voltage changed, it has no clue that the voltage has changed. Make sense, folks? Aryan, Alvin, Polka Dot, folks on the same page? Do you all want me to go again? Gaming Skull? Awesome. Great. So that's an analog signal. Perfect. I'm glad Crash Chicken you understood it too. Alright? Perfect, folks. I love how y'all are so responsive. No, I'm glad. I want everyone to reply yes. Anyway, cool. Great. So now this is analog reading. Okay. Next, we have something called digital reading. Now remember, we have 5 and 0. This is what Gaming Skull was talking about when he said using the threshold, right? A sensor is still giving you a digital sensor also can't give you a 0 and a 1. Even if it does give a 0 and 1, your microcontroller can't understand the 0 and 1. So how does the sensor tell 1 or 0? Well, the limitation is on the pin. What happens is your sensor is still giving a value, that is going like this. Okay, this is the value it's giving. Not specifically that much magnitude again, but it has a graph. It's not giving you a 0 or a 1 or a 0 and a 5. What the microcontroller understands is this threshold that, gaming style was talking about, which is 2.5. It's 2.5, right? Yes, it's 2.5, right? So what the controller will now do, right, for a sensor that is supposed to tell it 0 and 1, the sensor might be telling more. So if you connect an analog sensor to a digital pin, it's the pin that has the constraint. What will happen is the pin will basically put the threshold, right? 2.5 volts. It's not very accurate and it will depend on the reference voltage again. But the point is it's going to take half, right? From that half point, anything above that would be 1. Anything below that is 0. So if you get a controller, if you get a hands on a controller and you can actually measure this, connect an analog sensor to a digital pin, and it will still give you an answer, but it'll be 0 and 1. You can't get the numbers, the range of numbers, like 100 to 1023 numbers that you get in terms of the analog read. Makes sense, folks? So a controller, digital pin, will basically put a threshold on half of it. Anything even slightly above it, 1. Anything below it, 0. You never get 0 and 5 volts from a digital sensor anyway. Which also brings us to calibration, right? If you ever use an IR sensor, you can calibrate it based on the distance from the ground. Based on that, it sends a voltage, right? All you're doing is you're intensifying the threshold towards 0 and towards 5. So the ADC value, what do you mean by the ADC value? The magnitude value that I told you about, the 10-bit value, or are you talking about the entire graph and reading it? So, and your analog sensors, what are analog sensors? Anything that's giving you multiple things, right? Say a servo, right? An angle of the servo that you want to read, or a temperature sensor which has multiple ranges, right? It's not a 0 1. It can't tell you 0 1 for an entire range of temperatures, right? So those are all ADC values, all analog values that you want to read into your controller and send to your code for decision making. Make sense? Did I answer your question, Dreaming Godball? All right, Kunal understands it. Great. We'll take our time here because, again, you'll be able to do all of the things that we do hands on regardless of this. But this is really good understanding to have because this also explains to you, once you go ahead, when you look around, you'll be able to tell, okay, the fan is getting this value. My remote is sending this value. Awesome. I'm like, so gaming style, this is what you were talking about, right? The threshold for giving a 0 and 1. Yep, microphone that sends basically an analog signal. Although the circuit 2, that's an I2S, it's slightly fairly more complicated than just an analog signal, really. But basically, you amplify it and then you digitize it. That's what's happening. All right, folks. I don't see a lot of comments coming in, so I'm gonna move on. But if you all have any question, let's say you sleep on it today and you're like, okay, no, this makes absolutely no sense. We'll go over it again. Okay. Luckily for y'all, there are no sessions before and after mine for like a long time, most of the days, especially after. We can stick around, answer any questions you all have because we've gone a little too slow today, I feel. But it's okay. We're having fun. That's what matters. Okay. I don't understand this gaming skull. You're talking about the threshold, right? The threshold is there for digital pins. That's the only, it has a range of, basically 3 numbers: 0, midpoint, and the last one. All right, folks, let's move on. Let's go to our, very quickly, let's do digital signals. Okay, this is much easier. Okay, cool. So we've done digital reading. Writing works in a similar way. If you have an actuator and you want to give it 1, it anyway, so now this time the actuator, if it's a digital actuator, it will only understand 0 and 1. Okay, for example, an LED, Bad example, but if you give it a 0, it's not going to turn on. If you give it a 1, it'll turn on its highest brightness. Okay? Keep the LED example in mind, right? So 0, 1, you write out simple stuff. There's not much. So what is 0 and 1? 0 is no voltage or very trickle voltage, and 1 is basically all 5 volts or all 3.3 volts. The controller will give it to that point. Make sense? Everyone, digital writing is simple, straightforward. If it still does not make sense, I'm happy to break it down for you all. All right. Again, if you're using an analog write pin, we do not have analog write pins in Arduino, to be very clear. But if you have an analog write pin, which will be through a DAC, which is a digital to analog converter, Arduino does not have a DAC per se, right? So what happens is you're basically using a threshold. Anything above it will be considered 1, anything below it will be considered 0. So I hope that makes sense. All right, awesome. It makes sense to everyone. Great. Let's look into analog writing that Arduino does. So I already told you, Arduino does not have a, traditional DAC. All right, it does not have a traditional DAC. What it has is a fake DAC. Basically, it uses a lot of high frequency switching to emulate a certain state, right? It's like, my favorite example to give is this, have you all seen Ant-Man, the one in which there's the fluctuating lady, right? She keeps fluctuating between states, right? So she's there and she's not there, and in that, when she's doing that, her brightness changes, right? Her form is changing through brightnesses, right? Now, if she fluctuated at a constant rate, you would only see one brightness. Is exactly what we're doing here. So what Arduino does when it does says you can't have digital analog write, but you can write a PWM, is what it's saying is, if I very, very quickly, let's say this is my thing, I keep the LED on for a certain time and turn it off, right? So this is, let's say this is 75%. So I take a second, and for 75% of the second, I keep it on. And for 75% of the, 25%, I turn it off. And I keep fluctuating it very quickly, right? So much that you can't say that it's turning off and on. It will actually emulate 75% brightness. Kind of cool, no? So you're not writing analog signals. You are switching between digital signals so quickly that you're emulating a certain analog signal. Now, this is something what is called the pulse width and pulse width modulation, right? That now the name makes more sense. You're modulating the pulse width to emulate a certain sense of brightness or a certain sense of analog signal. So let's say you want to send 20%, you will turn it on for 20%, you will turn it off for 80%, and that 2080 can be basically a second or your entire time's percentage. Oh, there's no negative state, Adi snippet, right? Remember, there's no negative in our thing. So this is 0 and this is 5. It's turning off, which basically means it's getting a 0 voltage for 25% of the time, and 75% of one cycle, which is being repeated, it gets higher voltage. Make sense? All right, awesome. Okay, folks, I know that was again ton of information. Y'all did really well in absorbing it. I'm very proud of each one of y'all here. Let's go back to our Tinkercad. Let's connect a digital sensor. Let's connect an analog sensor, and let's connect a PWM actuator. So something we'll just use LEDs wherever we can because it's much easier to visualize it. Okay, and we have another 10-15 minutes to go. So let's at least get the circuits connected. We'll write the code and get them working tomorrow. Sounds good? That's the first thing we'll do tomorrow. I'm pretty sure they exist though, Alvin, No, this is not an exam. I will not be quizzing you on this. You all are here to learn, but mostly to have fun. So till the time it's fun, till the time it's you're actually learning something without getting bored or zoning out. Stick around. If not, we'll wait for me to get more interesting. I'll definitely figure a way. So this is like what the fourth iteration of this, and I keep switching up methods. I keep switching up the sequence, so it's never the same. The information, however, is always the same. You know what? I'm actually going to try and do that. How about I in tomorrow's presentation I add some memes. I will be taking suggestions on Discord. Same channel, just tag me and put the meme you want in the presentation, and I'll also give you all credit. Okay, folks. We just have a meme time instead of a break tomorrow. Folks, let's get back to our Tinkercad and let's get the components connected. That's it. That's all we do today. Tomorrow we'll make three different circuits for sake of understanding. We'll have in one an analog sensor and an LED, which will give you an output based on the analog sensor. Then we'll have another circuit with a digital input and a digital output. And then the last one, we'll experiment with PWM on the LED. Okay, so that let's start with that circuit because that's going to be the simplest, right? So share screen, circuit design. Let's first get the LED connected. Okay, so I'm going to pick up an LED. I want it to be yellow. Okay, so LED name 1, which is fine. I won't bother. Okay, so there's a cathode and an anode. Folks, which one is the positive one? Quickly. No one? Oh no, screen share. Thank you so much. See that I told you I do this at least once in the. I it was on my stream and I have to press another button to. It's okay, right? So this is the anode and this is the cathode. All right. So if you all don't know, always the longer end is your positive, which is anode. All right, and the negative one is cathode. So the negative is the cathode and the positive one is the anode. All right, so let's get it connected. Let's connect the anode to a digital pin, right? I'm not connecting it to a PWM pin right now. Okay. Next, the cathode. Remember, for completing a circuit, you need to complete a circuit for the component to work. So I can either connect the LED. So let's say I connect the LED directly to the 5 volt thing. So let's say I take the anode, 5 volts, skip, that's to connect the ground, connect it to the ground, right? It will turn on, right? Start simulation, it's on and it's also bursting because I've connected it to 5 volts. So it's also breaking, which is fine. So the circuit is completed. But precisely, ground is for the cathode. So that's correct, dreaming God ball, right? But cations are positively charged, hence they go to the cathode, which is negatively charged, and they get reduced there, right? And the anions, which are negatively charged, go to the anode, which are positively charged, and get oxidized there. Make sense? Basically, right? So cations, correct. And hence, because cations are positive, cathode is negative. Yeah. So how I remember that reduction happens on cathode, hence negatives. Sorry, oxidation happens on cathodes. That's how I remember it. I used to hate. I've never been good at chemistry, so I always had to come up with creative ways to remember. But you're good. You're good. I'm glad you asked. Right? Awesome. So basically, what I'm trying to do when I connect an LED is complete the circuit, right? So I can connect it directly to the voltage. But what I want to do is I want to control when the LED gets turned on, right? So I'll connect the ground to the ground still, but the voltage that enters LED through the positive end is what I'll connect to the pin, which I can control using code. Make sense? Yeah, folks, make sense? Awesome. So this is our simple circuit. Oh yeah, yeah, yeah. That's why it showed the red symbol also. But this is fine because it's a pin. We can control the voltage we're giving it, so that's fine, and that's okay. It's a digital thing. I would rather you all pay attention to the wire colors that you all are using from long for the reference sake, because that you can mess up rather easily. So digital, again, it doesn't matter, but connecting the positive to the negative and negative to the positive, your LED sensor, everything will for sure break down. That's such a nice suggestion. Yeah, even I had a mnemonic. I just don't remember it. It was something like it went something on, like, like anox or something on those lines. I don't remember, but yeah, that's a great way to go. All right, folks, all on the same page. Have you connected your LEDs? Let's connect our LEDs very quickly. That's a great question. I will do one thing and I'll curate a list of resources for you. Sounds good. From so tomorrow, I'll first share the resource list, or I'll just make a GitHub repo for you all, where you all can also keep a track of the code we go through. Of course, you might just blow your sensors or LEDs. We anyway, live for the stories. That's a great way to do it. I think we can stick to this legend: red for positive, black for ground, and green for digital, or green for any signal pins. That's a great question, right? So, what my point here was, you can connect this to any of the digital pins, right? You see, all of these are digital pins. Select, delete. Okay. So, you see, all of these are digital pins. You can connect it to any of these. I chose the digital pin only. You see the tilde pins? They're analog, they're PWM pins, right? So, you can connect. I just want to connect it to digital pin so I can show you how it works, right? So, you can connect it to 8, you can connect it to 7, wherever you want to, right? And the negative one will always go to the ground. So you can connect it to this ground, or if you do not have grounds left, you can connect it to a digital pin and then pull it to ground. Basically, write a zero to it. Make sense? Yeah, it's okay. We're just completing the circuits today, so we're good. We actually covered quite a lot. We still have some theory left, but that's okay. It's nothing y'all can't understand. We'll just quickly do a recap of these slides tomorrow. And so pull, in the sense, you can use code to write zero to that pin, and it'll actually act like a ground pin because you're giving it zero. You're basically pulling it to the ground. There's a sinking effect that's happening. Make sense? It's kind of cool, huh? And the same applies to 5 volt, right? That applies. So if you want to give something source of 3 volts and you run out of these pins, remember, you can always connect multiple pins using the breadboard. So you can just pull out the 3.3 volts here and connect all of them here, or you can pull out the 5.5 volt, or not the 5.5 volt, rather the ground, to another one and connect all the grounds here, which is also one way to go about it. But let's say you don't have a breadboard, you always have it digitally. But if you don't have it and you want to give something 3.3 volts or 5 volts, you just use one of these pins and pull it up. Basically, write a 1 to it. So it'll become a voltage pin. But remember, if this is a 5 volt controller, this will automatically go to 5 volts. Okay. And even if you do use a 3.3 volt PWM, it's always going to reach the 5 volt point. So you do not want to do that. If it's a 3.3 volt controller, you always use the 3.3 volt pin. Else, if it's a 5 volt, you can just connect it to any digital pin, any pin really, and just write 1 to it. I'll, you won't get banned, I'm sure, but in case you do, just let me know. Yes, we'll be using embedded C, but it's very simple. Arduino C is like super simple. You don't have to learn anything. Just remember to put a semicolon if you're writing it yourself, but that's pretty much it. It is so the final thing is a CPP type of a thing, but you can call it embedded C as well. You can write in both in that. You have to specify it's a CPP file, but an Arduino has its own extension called .ino is what we finally use. All right, folks, how are we doing? Has everyone connected an LED at the very least? Yes, assembly is a good. You know what? I think we can do an assembly coding session also at some point in the next GHW maybe. How do you feel about WebGL and OpenGL? Are you all interested? I've been planning to, do some sessions in that, but I kind of chicken out because I'm still learning it myself. I like there's so many yeses. I have no clue what the yes is for anymore because I've asked so many questions. Oh, we love 3JS. We could do 3JS, yes. All right, folks, has everyone connected their LEDs? And you know what? I feel let's just quickly connect our sensor, one analog sensor. Let's take a potentiometer. Potentiometer isn't a sensor. Potentiometer is a variable resistor. Basically, you can switch between its resistance, and based on the resistance, you'll get a different value. You can read that value and use it to control the brightness or the servo motors and it's one of the most common projects that you start with. Based on the potentiometer, you change the angle of the servo. Okay, so let's start with the potentiometer, right? Okay, so let's go back here. Let's take a potentiometer. So how a potentiometer works is you have terminal 1, you have terminal 2, and then you have the wiper, right? So the terminal 1 is what goes to the voltage, terminal 2 will go to ground again, and the wiper is what will basically switch between exit. Okay. The wiper is what you'll change the values for. So this is going to give you different values. So I'll just connect it to analog read pin because I want to be able to read different values, right? It's an analog sensor that we're using it like. So I'll connect it to the analog 1 pin, and I'll probably position it a little better. There we go. Let's delete the breadboard so we have space, and let's bring it here and let's flip it. There we go. Cool. This is good to some extent. Let's also, we can't flip this, never mind. Alright, so this is good. Remember, you can connect it anyhow in terms of the terminal 1 and terminal 2. Ground and voltage can be the other way around. Where are the negative pins? These are the tilde pins. Is that what you're talking about? The tilde? Those are PWM pins. Those are the pins that can do fake analog writing. Oh, that's because you haven't given any code to it, right? You're not turning. So even if I run my simulation right now, nothing will happen because my LED has no clue what to do. When I go into my code section, uh, so if I go into my code section, I stop simulating, and we won't be using blocks. We'll be using text. Okay, so continue. So you see, this is just writing the digital built-in LED, which is this L that you see, which is also connected to pin 13, by the way. So if I write to pin 13, this is the LED that will get toggled also. Over here, I'm going to put, so LED built-in is a macro that they're using. We don't need that. Our pin is 7 for LED. And this will depend on where you've connected yours. Okay, so 7. Let's make this 7. 3 times 7. No. Right. So I've connected to 7. Pin mode is output. As in I'm writing to that pin. I'm not reading from it. If it's reading a pin, I'll be putting input. So for example, this pin mode, copy, enter, paste. I'm going to make this into A0 is where I've connected my analog input. And I'll convert this into an input pin. right? Remember, this has to be all capital. This is syntax. All right. Now I'm going to do a digital write on my LED. So this is going to be my pin 7 again. You can also name the pin as a variable. So you can call int 7, int a equal to 7. That will take 7 as the LED pin. All right. We'll look into it tomorrow. Don't worry about it. Okay. And I'm just going to now start the simulation. And there you go. See, the LED is turned on now. Got it? Does that make sense, streaming codeball? You'll turn on once you put the code in it to turn on, because you've connected to a pin that you control via code. All right, folks. We're very much out of time. If you've connected your analog sensor and LED, that's great. We'll just work on this tomorrow, okay? And we'll connect more stuff as we go. Again, tomorrow, right? I've shared the slides with you all. Again, they're more like flashcards for me, and if they work for you as flashcards to remember what we've discussed, great. If you all want me to add a specific, any specific information, let me know. But let's just quickly go over whatever was remaining in the slide so that I can quickly go over what we're going to be doing tomorrow, maybe, right? So you've understood these two. Coding approach to analog embedded systems is what we'll learn tomorrow. And reference circuits, we'll look into them tomorrow also. So how do you start into IoT in case you all don't plan to attend sessions ahead? More code and more practice, obviously. The more you understand how embedded system or single device works, the more you'll be able to make them communicate with each other. We'll look into a little bit more about devices and architectures tomorrow, very briefly. Again, I'm doing a very superficial thing for you all so that you all have a vague understanding of everything rather than in-depth understanding of one thing and having no clue how the other things are working, right? We'll look into protocols. Then, if we have enough time tomorrow, or this will just, so what I usually do is I put as much content in the first two sessions, and whatever is left over, we let it overflow into the third session. So if we do get enough time, we'll make an entire project from scratch using simulators. All right? A fun picture again, because I like this picture so much. And then there's this, right? So there's a buy thing where you all can stay in touch. And I just realized I'm not sharing my screen again. What camera stick thing behind me? Give me 1 second. Let me realize. I just realized I haven't shared my. Oh, great! It barely turned on. That's great. You're already ahead of everyone now. But great. So this was the PPT I was going through. We already did this coding approach. You'll understand tomorrow. This is all that is next, is what I was reading out from. I didn't realize I hadn't shared screen. So we'll look into this tomorrow and continue as we go. We do have, I know that there are a lot of slots empty. So in case this ends up overflowing, we'll take another extra session and cover things. So don't worry. I'll definitely not go any faster than your questions. If you keep the questions coming, we'll stay on that topic. I think there is. I'm so sorry if there is. I'm over going into their session, but let me quickly just go through this one. All right. Again, a nice picture for you all to go into the next session with. And these are my contact details if you all want to reach out to me on any other platform and ask questions. All right, folks. I'm going to end the session now because you all have a really cool mini event lined up. And I hope you all have fun, and I'll see you all tomorrow. Bye, folks.